We are going to be solving this conditional equation, and I'm going to be making use of the PQ formula to do so. So let's go ahead and write down our quadratic equation, which is going to be x squared plus 9x plus 18 is equal to 0. In fact, I'm going to go ahead and label the coefficient of the x term as p and the coefficient of the constant term as q. And the reason why I've done this is because we're going to be substituting our values of our coefficients of p and q into the PQ formula. Now, our value that corresponds to the parameter P is 9. So we'll go ahead and substitute 9 into our formula. And then we're going to substitute our value of the parameter Q, which is 18, the value of that constant coefficient. Now what we're left to do is evaluate this expression. I'm going to be making use of this power of a quotient law, which says if I have a quotient raised to some power, then I can raise both the numerator and the denominator to that same power, leaving me with 9 squared over 2 squared. And we can actually evaluate both the numerator and denominator of that fraction. 9 squared giving us a value of 81 and 2 squared giving us a value of 4. Keeping focused in on the radicand here, we are going to find the difference of this rational value of 81 over 4 and the integer of 18. So in order to perform the subtraction, we are going to upgrade 18 to a rational value, expressing it as 18 over 1. We notice that the lowest common multiple of 4 and 1 is 4, so we will multiply 18 over 1 by 4 over 4, leaving us with a numerator of 72 over a denominator of 4. Now that we have that common denominator of 4, we can find the difference of the numerator, which is 9, over that common denominator of 4. To take the principal square root of 9 over 4, we are going to make use of a radical of a quotient law, which says that if I'm taking the principal square root of a quotient, then I can independently take the square root of the numerator and the denominator. And that leaves us with a numerator, which is the principal square root of 9, and the denominator, which is the principal square root of 4. Now, I can evaluate both the numerator and denominator. The principal square root of 9 evaluates to 3, and the principal square root of 4 evaluates to 2. And now I can go ahead and consider both our cases. Starting off with case 1, we are going to have x is equal to negative 9 over 2 plus 3 over 2. Case 2, we have x is equal to negative 9 over 2 minus 3 over 2. Evaluating case 1, we get x is equal to negative 3. And evaluating case 2, we get x is equal to negative 6. And we have now found the two roots of our equation, or we could say we found the solution set to our conditional equation, meaning that the values of negative 3 and negative 6, when substituted for x, will make our equation true. Now, before we're done, I want to take a quick look at this in a bit of a visual way. And I'm going to do that by plotting the graph set of the left expression by this blue curve. And I'm going to do the same thing with the right expression. I'm going to visualize the graph set of 0 using this horizontal yellow line. Solving the equation means finding the two points that are shared by these two curves. Now, we found the first one through our case 1, which was the point where x was equal to negative 3. And we found the second point shared by both of these curves, which is when x is equal to negative 6. There you have it. We have solved this conditional equation. My name is Mark, and thank you for watching.